Why is Mercury so hard to explore? Hello friends, I am Technosphere, and today we will talk about one major reason why we haven't been able to conduct many space missions to Mercury so far. Do you know which reason I am talking about? Well, first let me ask you, how many missions have we done on Mars? 30. On Venus? 22. In fact, we've sent 3 missions to Pluto, the farthest planet in our solar system. We've even sent 2 missions outside our solar system into interstellar space. Yet we've only sent 2 missions to Mercury, the closest planet to Earth. Yes, you heard that right. Mercury is closer than Venus or Mars. Despite being our nearest planetary neighbor, why haven't we explored Mercury much? Well, friends, you're going to be shocked when you find out the reasons behind this. The story begins on November 3rd, 1973, at Launch Pad 36B in Florida, where NASA's first probe, Mariner 10, was ready to go to Mercury. At the time, every scientist had the same question on their minds: would it successfully reach Mercury? This was the first probe designed to travel from Earth to Mercury without any fuel, solely using gravitational assistance. Surprisingly, after a few months, it became clear that their worries were unnecessary because the probe successfully completed its journey. However, something unexpected happened, as if all their efforts went to waste. During the final flyby, Mariner 10 ran out of fuel and crashed into Mercury at 5 times the speed of sound. It collided with Mercury's surface and was completely destroyed. The primary purpose of this probe was to send pictures of Mercury back to Earth. While it did manage to do so, it was still deemed unsuccessful. Why? Because other planetary probes are typically designed to take over 25,000 images, while Mariner 10 managed only 2,700, some of which were of Venus. On approaching Mercury, the probe started encountering unique problems that no other planetary mission had faced before. It struggled with these problems until it ran out of fuel and ultimately crash-landed on Mercury. Why is Mercury so challenging for space probes? For starters, the sun's heat, gravity, and Mercury's own reflectivity. Any probe heading to Mercury is influenced by 2 forces: the sun's gravity and Mercury's gravity. Which of these is stronger? Obviously the sun's gravity. This means that anything sent towards Mercury is more likely to be pulled into the sun rather than reaching Mercury. This is one of the biggest problems. Scientists came up with a solution: speed. The speed of the probe must be precisely set so that when it passes Mercury at high speed, it doesn't fall into the sun's gravitational influence, performs a flyby, and returns after capturing images of Mercury. Think of it like a race car slowing down on a curved road to stay on track. Similarly, for a probe to stay in Mercury's orbit, its speed needs to be reduced. But here's the catch. If the speed is too slow, the probe will fall into the sun or Mercury due to their gravitational pull. If the speed is too fast, the probe will fly by without capturing proper data. This is exactly what happened with Mariner 10. During its last flyby, the intense solar radiation caused the probe's path to deflect, pulling it into Mercury's gravitational influence. The gravitational pull increased, and the probe ultimately crashed into Mercury's surface. The energy produced in this crash was so immense that, had the probe crashed into Earth, it could have completely destroyed the Great Pyramid of Giza. Why do we still want to study Mercury? Despite all these challenges, why do we continue studying Mercury? Why did we launch another mission to Mercury in 2018? To answer this, let's explore some fascinating facts about the planet. Mercury is unique. The sun rises twice a day on Mercury. A single day on Mercury is as long as 2 Earth years. This means you'd celebrate your birthday twice a day on Mercury. Why does this happen? Mercury rotates very slowly. A day on Mercury equals 176 Earth days. A year on Mercury equals 88 Earth days. In simple terms, Mercury completes 1 day in the time it takes to complete 2 years. Why does Mercury rotate so slowly? This is due to tidal locking caused by the sun's gravitational influence, similar to how the Earth's gravity affects our moon. The sun's gravity has slowed down Mercury's rotational speed over billions of years. As for Mercury's fast revolution, that was determined when our solar system formed 4.5 billion years ago. During the formation, dust and gas around the sun condensed into a protoplanetary disk. Objects closer to the sun gained more speed due to its gravitational pull, while those farther away moved slower. This explains why Mercury has such a high orbital speed. Testing Einstein's theory of relativity. Mercury plays a crucial role in testing Einstein's general theory of relativity. Scientists have launched the Bepi-Colombo mission, which will study Mercury's atmosphere, chemical composition, and magnetic field. One of its instruments, the Italian spring accelerometer, is designed to detect space-time curvature in extreme gravitational fields, providing an accurate test of GTR. Additionally, it will investigate why Mercury's magnetic field is so weak. Mercury's core makes up 85% of its volume, compared to Earth's 20%, yet Earth's magnetic field is much stronger. Understanding this could provide key insights into planetary magnetic fields. Despite its challenges, Mariner 10 made significant contributions. It sent the first high-definition images of Venus, which earlier missions, Mariner 1 and Mariner 5, failed to do. It proved that gravitational assist could be used for space travel, paving the way for future missions. Today, thanks to this technology, we've sent probes into interstellar space and even captured detailed images of Pluto with the New Horizons mission. If you enjoyed this video, don't forget to hit the like button. See you next time, friends. Until then, as always, stay curious, keep learning, and keep growing.